Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today's our topic is orientation to your 10th class chemistry or Federal Board of Intermediate and Secondary Sciences. I'm Javeera Matiullah and I would be explaining you the prescribed book, notebook, practical notebook, your paper, and then we would discuss few topics of first chapter of your book. So Bismillahirrahmanirrahim. Our today's contents are prescribed textbook, resources, your notebook, practical notebook, chemical equilibrium, and the types of reactions that we have in chemistry. So first, your prescribed textbooks, textbook chemistry grade 10 of National Book Foundation is necessary. Then for your practical, for your notebook, single notebook is prescribed, and chemistry practical notebook is same for 9th and 10th. It's a combined notebook. So this is the cover of your book for 10th class chemistry. This is how your practical notebook looks like, and here is the front page or front cover page of your notebook. So let's start with today's topic, that is chemical equilibrium. So we would discuss what is a chemical reaction, what is a complete reaction, what are irreversible reactions, reversible reactions. Then we would have a look on the reversible reactions by using different graphs, and then I would explain what is chemical equilibrium. So if you just see this slide, by definition, a process by which one or more substances called reactants are changed into one or more substances called products with different physical and chemical properties, then this is known as a chemical reaction. And for a chemical reaction, if we just want to know whether the reaction is carrying out or not, then we have to see different changes which are taking place in the reaction. So there may be a change in the color, there may be the formation of precipitates. Now these precipitates are insoluble solid particles for a reaction. Then there may be a release of a gas. We may also observe a change in temperature or a production of sound during the reaction, or production of light during the reaction. Then the reactions may produce some odor. We may observe, we may smell something like that. And for every reaction to take place, we have to provide additional energy. Now this is how a chemical reaction looks like. We have, if you just observe, before the arrow we have Na and Cl, and after the arrow we have NaCl. Now this separate Na plus Cl, separately they are written. They are the reactants, the things, the substances, the elements which are written before arrow, they are known as reactants. And the substances or chemicals or compounds that are written after the arrow, they are known as products. So on the left side we have our reactants, and on the right side we have our products with us. Similarly, it's another example of a reaction, chemical reaction, in which NaCl it's converting into, NaCl is reacting with AgNO3, and then it is converting into AgCl and NaNO3. Now here what you have to observe, that with this NaCl I have written AQ, small AQ in a bracket. Now this AQ or this small s, it is representing the state of the substance, the state of this compound in which they are present right now for this reaction. So states of matter, we know there are main three states of matter: solid, liquid and gas. And here we have aqueous, it means we have just dissolved this NaCl in water. So from this arrow we would come to know that it's a complete reaction, because we have a complete arrow over here. In a complete reaction, all the reactants are converted into products, and products are not making reactants again. So this is the type of a complete reaction. Similarly, this is also a type of a complete reaction. A complete reaction is also known as irreversible reaction, because in this reactants are converting into products, but products are not again converting into reactants. So reversible reaction, I have shared a link over here. All of you can go through with this link and you would have a better understanding of reversible reactions. So here we have another example of a reversible reaction in which N2O4 is converting into 2NO2. It's a forward reaction. And for a reverse reaction, we have written 2NO2 converting into 2N2O4. And in the third one, we have written both the reactions simultaneously. We have shown this by using two half arrows. If you just observe, we have two half arrows over here. So we have just written both forward and reverse reactions at the same time, because they are taking place at the same time. So we say it's a reversible reaction. From this arrow we would come to know whether the reaction is reversible or irreversible. If we would have two half arrows, then we would say it's a reversible reaction. And if we would have a complete arrow, then we would say it's a complete reaction or it's a irreversible reaction. Okay, so here we have differences between forward and reverse reaction. The forward reactions are those in which only reactants can be converted into products, and for a reverse reaction, reactants can be converted into products as well as products can be converted into reactants again. Then for a reverse reaction, it proceeds in only in one direction, while reversible reaction or reverse reaction, it proceeds forward as well as backward. So it moves in both the directions. Now this irreversible reaction or forward reaction, this is represented by a complete arrow, while reversible reactions are shown by this two half arrows. Okay, so reactants are completely converted into products, while in this case, in reversible reactions, reactants are not completely converted into products. Those products are again making the reactants. Okay, so in reverse reaction, in irreversible reactions, when the reaction is complete, only we have products. While in reversible reactions, when we would have equilibrium, then we have equal amount of reactants and products.